Zabbix is an open-source IT infrastructure monitoring system. It uses templates to provide customized management of switches and routers from many manufacturers. In this video, I will demonstrate how to create a template to manage Hirschmann Industrial Ethernet switches running the HiOS operating system. If you are new to Zabbix, this video will help you to get started with customization. If you are familiar with Zabbix, then you will gain some knowledge about Hirschmann switches. For this demo, I used the Zabbix virtual machine, and I was truly impressed by how it worked out of the box with no setup effort. Zabbix is flexible software, and there are multiple ways to build a device template. As this was also a learning experience for me, I chose a sequence of tasks which would highlight errors as soon as I made them. These are the tasks we will now run through in the video. I started by creating a dummy device in Zabbix, which is a temporary device I could later use as the foundation of my template. This allowed me to configure and test a variety of different supervised values. Once I was happy with my dummy device, I converted it into a Hirschmann template. I then added some enumeration to the template to make the values more readable. In the next step, I configured some alarms in the template. The final step was to configure Zabbix to find my Hirschmann switches and correctly add them to the list of supervised devices. So let's get started. In this section, I will create the temporary dummy device. Specifically, my objective is to create a template to supervise devices which are running the Hirschmann HiOS operating system. So I'm using a real Hirschmann RPS-35 as the basis for my dummy device. In fact, any HiOS device would work fine. I already decided which manufacturer-specific parameters I want to use. In case you want to follow along with the demo, I've added the parameters with their MIB OIDs in the video description below. This is my Zabbix dashboard. Currently, Zabbix is only supervising a single host, itself. So in the host availability widget, you can see one Zabbix agent and no SNMP agents. In the host screen, there is also a single device, the Zabbix server. So let's create the dummy device. I'll use dummy as the host name. Each host must be a member of a host group, so I select the discovered hosts group. The next step is to add the communication interface. I want to use SNMP. The IP address is the IP address of my RSP35. In my demo network, I use SNMP v3 with authentication and privacy. I know this is not a very secure passphrase, but it's only for my demo network. The dummy device is added to the list of supervised devices, except, as you can see, the availability is grayed out. This is because I have not yet provided Zabbix with any parameters it can poll, so the availability is unknown. In the dashboard, the system information is showing 2 hosts enabled, and the host availability is showing an unknown SNMP host. Now on my dummy device, I'll configure some MIB OID parameters to be monitored. In Zabbix, the parameters are called items. As I mentioned earlier, I already created a list of MIB OIDs I want to supervise. Before I create the first item, let's take a quick look at the list. The text in bold is a list of information categories. The text in uppercase is the name of the MIB which contains the information. In the next line, the first text is a real English name I gave the parameter, followed by the OID name, followed by the OID. Then I listed any enumeration, including the possible values, the status from the MIB, and some real English statuses where necessary. Now I'll create the first item, which will be temperature. The type is an SNMP agent. The key needs to be unique for each item in the system, so I use a prefix of HiOS. The temperature value is a number, so the type of information is numeric. I take the OID from my list. Units is a description field to clarify the value. I'm using degrees Celsius. It's unlikely that temperature will change quickly, so I use an update interval of 1 hour. Now the important part. I want to test the value to ensure I have not made a mistake with the configuration. The test was successful. The returned value is 39 degrees Celsius, so I can add the temperature item to my dummy host. Adding the remaining devices just uses the same process. To save time, I'll fast forward the video. Just pause the video if you need more time on an item. I'll also pause the video if I want to describe any deviations. ACA stands for Auto Configuration Adapter. It's removable memory which can be used to store the switch configuration. The Hirschmann HiOS switches have 2 power supplies or inputs. There's only one MIB OID for power supplies, and the instance, the last digit, is used to distinguish between the power supplies. So in my list I used an X as a placeholder. Until now, all the values returned by the switch have been numeric. For the next 3 items, device description, serial number, and software version, the switch will return alphanumeric strings. So the type of information needs to be character. As you see, the value is a string. Finished. My dummy switch now supports 12 product-related items, all of which have been tested. I go to the Monitoring Hosts menu and click the latest data link for the dummy switch. Now you can see the most recent value for each item, apart from the software version which has not yet been read. To avoid waiting for the update period, I will refresh the screen. Perfect. As you can see, some items are shown with numeric values, even though the values are not meaningful. I'll add the enumeration in a later task. Let's just check the dashboard. The dummy SNMP host is shown as available. The dummy switch is now complete and all 12 items have been tested, which gives me confidence that I've configured them correctly. In the next step, I'll create the Hirschmann template using items from the dummy switch. The dashboard shows a single available SNMP host, which is the dummy switch. Now I'll create the new Hirschmann HiOS template. I'll add some tags to highlight the purpose of the template. Here is the new template, but as you can see, it does not contain any items. Now the purpose of the dummy switch will become clear. I open the dummy switch items and select all 12. Then I copy these tested items into the Hirschmann template. Let's check the template. It now contains the 12 items which were originally associated with the dummy switch. At this point, the dummy switch has fulfilled its purpose and I no longer need it, so I will just delete it. Okay, it's gone. Now I'll manually add a new device. I'll use the same RSP35 switch that I used to create the dummy. To begin with, I will not add a template to this device. You've seen the interface before, so I'll fast forward. There's the new device. But the availability is grayed out and no data has been collected. You already know why. So I'll edit the device and add the Hirschmann template. Let's check the collected data. I need to wait for the polling interval. There we go. At this point, you might be wondering what is the purpose of what I showed you. All I did was create a device, delete it, and then recreate the same device in a different way. So now I'll show you the benefit of templates. I want to create another device. This time I'm going to add a BRS50. This is a different product to the RSP35, but it also runs the HiOS operating system. I add the Hirschmann template. You've already seen everything else, so I'll fast forward. Wait for the polling interval. There. Different device description, serial number, and software. All these items were taken from the template without me having to manually enter anything. But you may have noticed that there is a problem. Look at the ACA Status item. No such instance for this OID. The value is missing. Let me explain the problem. The template was designed for an RSP35 switch, but I've applied it to a BRS switch. Both switches support ACAs, but they are different types of ACA. So the MIB OID is the same, but the instances of the MIB are different. Probably the best option would be to create a different template for the BRS. It would be very little work. But for your information, I'll show you some other options. You may be wondering why I cannot just change the MIB OID instance. Let's try. You see that all the product-related fields are grayed out and cannot be modified. This is because all the information has been inherited from the template. The only way to change this information would be to change the template. But then every other device which is using the same template would also be modified. So this is something to bear in mind about templates. The easiest way to get rid of the error is to disable the item. Now you see that the BRS only has 11 items and the ACA status item is gone. But maybe you want that information. If you only have a few devices, there is another option. Let's go back to the original item. This time I will clone the item. Now I can edit it, but to be clear, I am not editing the template. I am only changing the item which is linked to this specific device. In any case, the key must be unique. It works. The BRS has 12 items again, and there is the value. So now we have a working template which really speeds up adding items to new devices. But as you saw in the last screen, the display is a bit unfriendly. Many of the values are shown as numbers rather than descriptive text. Converting numeric values to text is called enumeration, and that's the next task on the list. Here is the dashboard. We now have 3 hosts, 2 of which are our SNMP-enabled Hirschmann switches. Let's look at the polls data again. As I mentioned before, it's not easy for an operator to understand the status of the items. We need enumeration. To begin with, I'll open up my MIB OID list. Where enumeration makes sense, I've included it in the list. So now I'll work through the list. Enumeration is added to the template, which means that all existing devices will be updated and all new devices will inherit the values. In Zabbix, enumeration is called value mapping. I'll add the first value map. The value maps are not directly related to any item. The same value map can be linked to multiple different items. I copy the mappings from my list, but I use the text that I would like to appear in the status screens. That is the first mapping complete. The principle is the same for all mappings, so I'll fast forward the video. I mentioned that some mappings will be used for multiple items, and the enabled-disabled mapping is a good example. So I've given it a descriptive name rather than calling it high discovery status. Okay, that's the mappings entered. Now I'll link the mappings to the items. Let's do the ACA status first. The principle is the same for the others. Finished. Now I'll go back and check the hosts. Much more informative. The template is looking good, and the values of the items are readable. What's needed next is a way to generate alarms based on the values of the items. Alarm values and thresholds are very specific to individual networks, so I'll just create a couple of alarms as examples. You'll need to create alarms which are tailored to your own network's characteristics and performance. In Zabbix, alarms are called triggers. I'll configure them at template level, although it's highly likely that you will need to configure them at device level. Remember that you can do this using the clone option to clone an item from the template onto a specific device. The first trigger I'll create is for power supply 2. I open my MIB OID list to check the possible values. Warning seems like an appropriate severity for a failed redundant power supply. Next, I create the alarm condition. The expression for the condition can be very comprehensive, but in this case I only want to know if the value of the power supply status is greater than 1. The second trigger will be for the security status. Security deserves a high severity. You can see in the list that there are only 2 possible values, and I'm interested in the value 2 for error. Now let's go back to the dashboard. That's interesting. The RSP has a problem with power supply 2. Which is true because I only connected one power supply. Let's double check anyway. Yes, it's defective. What I'll do now is create a security problem on the BRS switch. There it is. In the Problems by Severity widget, we now have one high and one warning alarm. Now the template is looking quite useful, but there is still one final task. So far, I've been entering the switches in Zabbix manually. This is okay for a small network, but it's not scalable. We need automatic discovery of Hirschmann HiOS devices and automatic assignment of the Hirschmann template. For discovery, I will use SNMP v3 with the credentials I've used throughout the video. This means that devices with different SNMP v3 credentials will not be discovered. For template assignment, I will use the System Object ID MIB item. This will discover all Hirschmann devices, even though the template is only designed for HiOS-based devices. But in my network, I only have HiOS-based switches. Depending on your network characteristics, other options for discovery and assignment might work better. As you can see in the dashboard, I've deleted the switches we used previously. There are no SNMP hosts in the network. This time I'll use the Configuration Discovery menu to create a discovery rule. The name is descriptive. The IP range is what I use for my demo equipment. Just for the initial discovery, I changed the update interval to 1 minute. For live operation, a longer interval between polls would be more appropriate. The discovery check is the SNMP value that will be polled to determine whether a device is present. I'll poll the system description to look for any Hirschmann devices. You've seen the SNMP v3 credentials a few times now. For discovered devices, I want the host name to be the value returned by polling the SNMP variable above. Now I configure what actions should take place depending on the device's response to the discovery poll. In this case, I want to take an action if the response from the device contains the word Hirschmann. The next step is to define the action. This is where I link the Hirschmann template to the Hirschmann device. So I select my Hirschmann template. But that is not all. The Hirschmann template contains manufacturer-specific information. But for daily operation, we also need some standard MIB2 information, such as system and port data. Zabbix has a built-in template for this called Network Generic Device SNMP. Good. The discovery IP scan range, the SNMP credentials, and the actions are complete. All that's left is to start the discovery process. The discovery process has found 3 devices. Let's take a closer look. You'll notice far more data items than we had before. This is because I included the standard MIB system and port information template. Standard graphs are also available, empty at the moment because the devices have only just been discovered. Let's make a final check of the dashboard. 3 SNMP hosts and some security alarms. That brings us to the end of the video. You now have a solid foundation to build your own templates. Every time I use Zabbix, I find other interesting functions, and I'm sure you will have the same experience. So take some time to learn more about Zabbix, then create templates which are truly tailored for your network.